Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat sejahtera kepada semua murid SMK Komunitas Nanas dan juga kepada semua murid yang sempat mengikuti live channel bersama Seizat untuk mata pelajaran Matematik Tambahan. Okey guys, hari ini kita akan belajar satu tajuk yang penting iaitu chapter 8. Okey, untuk form 5. So tajuk untuk hari ini ialah taburan kebarangkalian ataupun kita boleh panggil sebagai probability distribution. Okay, this topic very important for your information. Okay, because this topic will be come out in paper 1 and also paper 2. So you don't have any choice, you need to answer. Okay, you have to answer the question of this chapter. Okay, this chapter alone will contribute around 10 marks. Okay, after we convert the marks, so it's about 10 marks. Alright, it's about 10 marks for this chapter. So please make sure you guys can understand this topic and also make sure you don't have a problem to answer the question. Okay, so before we start, as usual, my CBN girls, please update your kehadiran, your attendance on my right side here on the live chat. And for those new to this channel, okay, our main reference, okay, our module, I already provide to you the link, okay, in the description below. So you guys can download the module and we use that module to solve the problem, okay, to discuss today. Okay, I will show you this chapter 8. Okay, this one. Alright, guys, this is the chapter 8, probability distribution. Okay, so this chapter actually got two main title. Okay, number one is we call binomial distribution and the second is we call normal distribution. So my objective of today is I want to introduce to you the binomial distribution only. Okay, we learn one topic only for today. Okay, so let's go through the mind maps here. Okay, so chapter 8, okay, the probability distribution. Actually, okay, number one, this is number one, the first title of the chapter 8, 8.1, binomial distribution. So binomial distribution we can labeling as X, okay, B bracket N bracket P. Sorry, N comma P, right? So what is N, what is P, etc, etc. B stand for binomial, all right? So in this subtopic, we're going to learn three things, okay, in this binomial distribution. First, how we find the probability in binomial distribution, followed by how we sketch the graph for binomial distribution. And lastly, we are going to learn how to find mean, variance, and standard deviation based on the binomial distribution. This is the last part. Okay, guys. So, number one, number two, and number three. So we are going to go. We will go through all these three subtopic today. Okay. So number one here, how to find the probability. Okay, to find the probability in binomial distribution. Okay, this is the formula. This is the formula for probability for binomial distribution. Okay, where the P stand for probability, X stand for the binomial, okay, the symbol of binomial, R stand for the number of successes, or we can also call R also we can call as the number or the event that we want to find the probability. Okay, so N stand for the number of trial, and here stand for number of trial, or we can call as the other name for N is sample space. Okay, the sample space, okay, of the problem. And P, the small p, this is small p, this is capital P. So for the small p stand for the probability of success. Okay, this is a small p here, power of R, and the Q is probability of failure. So that means we got P and Q here. So if we know the value of P, so we can find the value of Q. How? This is the formula. To find Q, you must let equals to 1 minus the P here. Okay, that's how we find the value of Q. Okay, guys. So this formula very important. Okay, if you have a problem with this formula, then you cannot solve the problem for this chapter. So make sure remember this formula. Okay, so let me write again. So actually the formula is like this. Okay, Px equals to R equals to NCR. This one Go back to the chapter 6, right? Permutation and combination. This is the formula. But we combine with p, small p to the power r, and the small q to the power n minus r. Okay, so what we need to do is we need to find all the element here. Okay, all the element here we need to find, and how much r, p, q, etc. Okay, then we can solve the problem. All right, so let's look at the example first. All right, example 1. Now, in a town, okay, in a town, the probability that rain will fall, okay, rain will fall. Now, the story is about the rain, rain will fall on that day. Okay, the probability of raining is 0.3. So, what does that mean? So, from here, we know that P equals to 0.3, the small p, not the capital P. Okay, so the probability of raining of that day will be 0.3. So from there, okay, if you look at here, I told you after we find the P, we can find Q, right? So how to find Q? 1 minus P. The probability of failure, what's that? So from this story, Q will be the probability of the day is not raining. There's no raining on that day. Okay, so the answer will be 0.7 here. Okay, so how I get this? 1 minus P. Okay. All right, that is your P and Q. This is the two parameter that we already obtained now. So what's next parameter that we need to find? Okay, P, the small p and Q already find. Okay, how about N and R? N and R here. Okay, calculate the probability of rain will fall exactly 2 days in a certain week. So from this question, okay, what we can define is, okay, we want to find the probability exactly 2 days. That's why we put equal here, exactly 2 days. Okay, so that means your R actually 2. Okay, so this is a 2 days among what? Among a week, right? In a week. So in a certain week, how many days in a certain week? There's a 7 days. So your N, your sample space will be 7. Okay. Your N, actually, I told you just now, N stand for number of successes, or we can also, number of trial, but also we can say like N also known as a sample space, right? So we know that a week, we got 7 days. So that's why I labeling N equals to 7, R equals to 2, because exactly 2 days. So what we need to do is we just sub every parameter into the formula. So NCR, right? So I write down the formula first so that you can fill in the blank. So your N is 7, CR 2, P 0.3 to the power of, okay, this is power R, right? How much the value R? Power 2. And 0.7 N minus R, that means 7 minus 2. How much you get? You will get 7 minus 2, which is equals to 5, right? So just substitute, just calculate everything, use your calculator. So how much will be the answer? So 7C2 times 0.3 to the power squared times 0.7 to the power of 5. So the answer that we are supposed to obtain is 0.3 something. Hopefully you guys can see, okay, 0.3 something here. So this is the probability. Okay, 177. So 0.3177 is the probability of exactly 2 days will be rain in a certain weeks. That's all. 3 marks already. So is it right? So this is one of the example. Question can come out in SPM. Right? Now look at the example number 2. So example 2, the probability of a durian chosen at random, okay, is about durian from a basket is rotten. Okay, now we are the story is about rotten durians. Okay, so probability of choosing rotten is 1/20. So P equals to 1/20. Therefore, we can straight away find the Q. The durian that fresh, that is not rotten, will be 1 minus P, right? 1 minus P equals to 19/20. Because because 1 minus 1 over 20, this is the value. Okay, now P and Q we already obtained. So calculate the probability exactly 3 durian. We are talking about exactly, that means equal. So your R equals to 3 are rotten if a sample of 10 durian is chosen. So your sample space is 10. Okay, your sample space, the sample space of the durian is 10 because this one, 10 durian is chosen. So we want to find the probability exactly 3 is rotten. So probability binomial equals to 3, right? Equals to N is your 10C3. P is 1 over 20 to the power of 3, and Q is 19 over 20 to the power 10 minus 3 equal to 7. Okay, now you compute, then you get the answer here. All right, so 10C3 times 1 over 20 power 3 times 19 over 20 to the power of 7. Okay, this is the value, 0.0 something, 0.01 something, right? So, write down here 0.01048. That is your probability, all right? So, 0.01048, settle. Okay? So hopefully you guys doesn't have a problem, So if you have a problem, please state your problem in the in the live chat here. So or if you have a problem also after this, please state your problem in the comment section of this video, right? Now look at the example 3. Okay, example 3, what we have here. So percentage, 65% of Form 5 students of a school pass the SPM additional mathematics paper. So 65%. Now guys, you already learned the probability before. Okay, so according you learned the probability in modern maths and also MS in the previous chapter 7, right? So 65% we can convert become a probability, which is, okay, now we are talking about passing. Okay, pass the paper. So your P is 0.65 because 65% equal to 0.65. Now the probability of people or students fail the paper will be 0.35. How I get that? Okay, how I get this value? 1 minus P. Okay. If a sample of 5 students, that means your N, not R, N. Your sample space equals to 5. If sample space of if a sample of 5 students are chosen at random, find the probability that all of them pass the paper. All of them, that is your R, right? Your R. When we talk about all of them, that means all the people, all the students we chose are passing the paper. So R equals to 5 also. Okay. Now, therefore, the probability when all the students pass the paper x equal to 5 equals to 5C5, 0.65 to the power 5, 0.35 to the power of 5 minus 5, 0. So, compute 5C5 times 0.65 power 5 times 0.35 power 0. So the answer is like this, 0.11 something. Okay, so the answer is 0.11603. Okay, I taking 5 decimal places. If you want to write 4 decimal places, it's okay, no problem. And at least 3 decimal places, at least 3 decimal places. All right. So that is your number 3. Settle. Now, number 4, very interesting this question. I prefer this question compared to the first, second, and third because in SPM normally example 4 is the question. Normally, okay, not every time, but selalunya, selalunya. Okay, so the probability of Daniel will win the tennis competition is 0.8. That means that is your P. Winning the competition. Okay, so list down your value. P equals to 0.8. So automatically we can find the Q 0.2, 1 minus P, right? If a total 5 games are played, that is your N equals to 5. Sample space. You are playing how many times? 5 times. Okay. So find the probability that exactly 3 games. Exactly. So to solve the problem A, your R equals to 3 here. Exactly. So probability will be X equals to 3. So we just substitute everything. Your N5 C3 0.8 to the power 3, 0.2 to the power 5 minus 3 equals to 2. Then you compute, then you get the answer. Okay, so kat sini anda akan dapat 5C3, 0.8 to the power of 3, 0.2 to the power of 2. So the answer is like this, 0.2 something here. Okay, so write down here 0.2048. Done. That is your value for A. Exactly 3 people. Exactly 3 games win. Now, how about B? Yes. Interesting the question B here. At least 3 games he win. We are talking about what? Inequalities here. This is what we call inequalities. We call at least. So that means your R will be at least 3. That means it can 3 onwards. Okay, so at least 3. That means it can be 3, 4, 5, etc. etc. So it can be X more than or equal to 3. This is how we write for question B. Okay, at least 3 games he won. So it can be 3 onwards. All right. So before we solve this problem, we need to elaborate this thing. Okay, we need to elaborate X more than or equal to 3 here. So actually it can be P X equals to 3, or when we talk about or, it will be plus. Or it can be on the 3, right? Which is X equal to 4. 4 games he win. Or another plus, it can be X equal to 5 game he win. Or X equals to 6. Now, this one, is this possible? So, if you're asking yourself, is this possible, X equal to 6? Look at the question actually. Actually, our question is only 5 games are played. So, this one, X equal to 6, that means 6 games are played. So, this is impossible. So, we stop until X equal to 5. So, make sure when you want to elaborate these inequalities, equals to 3, equals to 4, equals to 5, make sure you have the limit. Your limit is based on your sample space. Your sample space is 5 games. That means the maximum value will be 5. It cannot be beyond that 5. Okay? So please be careful. So what you need to do is, okay, substitute the value for 3, and for the value of 4, and for the value of 5. So n, how much your n here? Okay, 5, 5C3, 0.8 to the power 3, 0.2 to the power 5 minus 3, 2. Or this one, 5C4, because our R is 4 now. Okay, 0.8 to the power 4, 0.2 to the power of 1, because 5 minus 4, 1. And lastly, all the games he win. That's why X equal to 5. So 5C5, 0.8 to the power 5, 0.2 to the power of 5 minus 5, 0. So compute, then you get the answer. Okay, you compute everything plus together, then you get the final answer. Alright, this one I leave it to you. Alright, now let's look at the C here. Okay, question C. Not more than 3 games. What's that? Another inequalities. For question C, not more than 3. That means 3 is the maximum. Okay. The other keywords can we use here, at most 3 games. Okay, not more than or at most, they are same meaning. Okay, not more than 3 or at most 3 games. That means the maximum game that he can win is 3. It can be 3 or less. It can be 3, 2, 1 or nothing. There's no winning at all. So So the sign will be less than equal 3 here. So for question C, not more than 3, that means less than and equal. Alright guys, so before we solve the problem, I told you, you need to elaborate. Okay, you need to elaborate like this. So the maximum is 3. So we can start, there's no winning at all possible because less than 3. Or only one game's winning, or only 2 games winning, or another one, another plus here, only 3 games he win. Can win 4 times? Cannot, because the limit until 3. Alright, so just substitute everything. So 5C0, 0.8 power 0, 0.2 power 5. Okay, plus 5C1, 0.8 to the power 1, 0.2 to the power 4. Okay, 5 minus 1, plus another 5C2. A lot, there's a lot of number that you need to substitute here. Please be careful. Okay, and last one is 5C3, 0.8 to the power 3, 0.2 to the power of 2. Okay, guys, compute. Slowly, compute. Okay, I'm using another calculator here. Okay, 5C0 times 0.8 to the power 0 times 0.2 power 5. Okay, plus 5C1 times plus 5C2 times 0.8 power 2 times 0.2 power 3. And 5C3 times 0.8 to the power of 3, 0.2 squared. Okay, this is the answer that I obtained. Okay, I convert into a decimal, so it becomes 0.26 something, 26 something. So that is your final answer. 26272. Okay, 5 decimal places given here. All right. Okay, guys. Now, for question C here, if you look carefully, okay, I want to find the probability that less and equals to 3, right? The probability dot the winning is not more than 3. So I need to list down the 0, how much the probability for 1 game winning, how much the probability until 3. So there's a lot of numbers here, right? So do we have another way to solve this problem? Okay, so for question C, actually we got alternative way. Okay, alternative way. So the alternative way, how we find the final answer, actually the total probability is actually equals to 1. You must remember that. The total probability equals to 1. Okay, so it will be, since we want to find the probability of not more than 3, so what is the winning value that we want to deduct here? Okay, so we got 5 games we play, this guy play, so we want to find the probability that 3 to and below. So that means the 4th game and the 5th game we can minus, okay, we can deduct from the probability. So actually 1 minus probability when x equals to 4, and also minus the probability when x equals to 5 games. So that means if you want to find the probability that he win not more than 3, that means 3 and the bottom, okay, 3 and below, so we can also use 1 minus the probability of he winning 4 times or he winning all the 5 times. So the final answer will get the same value here. Okay, so 1 minus 5C4, okay, 0.8 squared, 0.2, 0.8 power 4. 0.2 power 1 minus 5C5, 0.8 to the power 5, 0.2 to the power 5 minus 5, 0. So the final answer also same like 0.26272. Okay, you guys try for this one. Okay, please try. Okay, why this one is very important? Why we need to think the alternative way? Because if the numbers here, if let's say our I want to find, okay, let's say the total games play is 100 games, let's say 100 games. So I want to find the probability that he winning is not more than 98 games. So X not more than 98 games. So I need, if I'm using the first method, I need to list down from X equal to 0, 1, 2, 3, 5, blah, 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 until 98. It's very difficult, right? That's why we need to think the other way. Okay. So actually to find this probability, we also can use 1 minus probability of X equals to 99 minus P X equals to 100. So that is the alternative way. Okay, please be careful. All right. So that is the topic for probability in binomial distribution. Settled, done. Okay. So now, okay, this is activity 1. So I leave it 1. I'll give you 1, 2, and 3 questions. So you guys can try yourself. Okay, as usual, if you have a problem, please state your problem in the comment section. All right. So I will discuss after that. All right. So this one is your exercise. All right. Now settle the first part. Now we look at the second part. The second part is about the binomial distribution graph. I told you just now in the before we start the topic. Okay, first thing we are going to learn how to calculate the probability of binomial distribution. Number 2, after we obtain the binomial probability, how to sketch the graph. We want to put all the data that we obtain, all the value into the graph. That's all. It's very easy. Semudah ABC. Okay, so don't worry, it's easy as ABC here. All right, now look at example. For this one, I give you the solution. Okay, already, because easy. This one easy. Okay, a fair coin tossed 4 times continuously. Okay, guys, when we talk about coin we got head and tail, right? Okay, head and tail. So please be careful. X represent the number of times of head appear. So head, we are talking about head. List the possible element of X. That means we are talking about sample space. All right, sample space. If I toss first time, if I toss 4 times, is that possible there is no head at all? Yes. That's why X equal to 0 first. Among that 4 times I toss, is that possible only 1 times head appear? Also yes. So the possibility of head to be appear, it will be 0 until 4 times, right? Why 4? Because we toss 4 times, so all the 4 times we got head, and head. So that's why equals to 4 final. Okay, so 0, that means there is no head at all. So all the 4 times you toss is given, the image given to you will be tail, and tail. That's all. That's why equals to 0. Okay, so this is the meaning of 0, right? Okay, settle for A. Now, calculate the probability for the occurrence for each element of X. That means we want to find the probability when there is no head, or when only 1 head, or 2 times of head appear, or 4 times head appear. Alhamdulillah. So guys, to find the probability for all these certain element 0 until 4, so we're using the binomial. Okay, so this is the formula. Okay, n equal to 4 because we toss 4 times. Okay, the probability to get head, that's why I told you, head and tail, right? So probability to get head is 1 over 2, right? That is your P. So your Q will be 1 minus P, 1 over 2 also. Okay, P, Q, and N here. All right, guys. Now, what is the probability when X equal to 0, X equals to 1, X equals to 2, 3, and 4? Now, I show you already. So when there's no head appear, so the probability binomial will be 4C0, 1 over 2 to the power 0, 1 over 2 to the power 4. 4 minus 0 equals to 4. So this is the probability when there's no head at all. When only one head appear amongst all four toes. So for C1, blah blah blah, 1, this is the value. So all this value, I think you don't have a problem because we already discussed how to find this value, okay, on the previous topic. All right. So after we got all of this, okay, look at the question C. Hence, plot a graph to represent the binomial distribution of X. So to plot the graph, okay, all this value here, okay, I transfer into a table. I tabulate a table. Okay, when R, this is your R, when R equal to 0, how much the probability? R0, R0, this is your probability. When R equals to 1, this is your probability, 0.25. R equals to 3, 0.25 again. R equal to 4, 0.0625. R equals to 2, 0.375. Just tabulate a normal table based on the probability that you obtain here. Okay, so what's next? How to sketch the graph, right? Okay, so as normal, just do the normal sketching of the graph. You already learned this sketching graph in mathematics, okay, in modern maths, chapter 2. Okay, so 0, 1, 2, 3, 4. Yeah, this 0 represent the value of R, is not the origin. Always remember, this 0 stand for R equals to 0, not origin. Okay, this is your origin. That's why there's no 0 here. We put 0.0, 0.1, blah, blah, blah. And then this 0 because of R. Okay, not 0 of origin. Okay, so when R equal to 0, the probability is 0.0625. So we just sketch 0.0625 here. Okay, just do the normal plotting here. Okay, plot. Okay, I just cross like this. Okay, so what we need to do is we just draw a straight line towards our plot X here. So this is the graph. Okay, make sure what is the common mistake made by the student. They connect all the dots. That what if you connect all the dots like this, for instance, okay, if you connect all the dots, it will be wrong. Please don't connect all the dots. Just draw a straight line vertically towards the X cross. Okay, X plot. Okay, so that is your graph of binomial distribution. Settle. Okay guys, sangat mudah. Okay, now next. Oh, now we already on the third lesson of the day. Final. Mean, variance, standard deviation of binomial distribution. So guys, this is three terms, okay, three terms that you learn in statistics, but in probability also we have this kind of term. So the formula, okay, right, let me change. Okay, the formula for mean, this is mean, the mu or micro. Okay, the mu equals to NP. N, we know, right? N stand for the sample space. P stand for the probability of success. Okay, standard deviation, sigma squared here, NPQ. Okay, so Q stand for the probability of failure. So to find the standard deviation, you just square root your variance. Okay, you square root the NPQ, right? So let's look at the example here. Example 1, 40%. Another percentage, so straight away convert become a probability. So 40% of student in a school wear a spectacle, so your P equals to 0.4. So the people not wearing the spec is 0.6, which is 60%, right? So that is your first parameter. From a sample of 10 students, so that means your N equals to 10. Calculate the mean, variance, and standard deviation. Okay, guys, this is not this question is not talking to find the probability, but this question want us to determine the mean, variance, and standard deviation. Now, this is your mean, right? Mean equals to NP. Your N, number of sample space, 10. Your P, probability is 0.4. So how much your mean for? Very easy, right? So how much your variance? Your variance will be NPQ. And 10P 0.4, Q 0.6. So calculate 10, 0.4, 0.6. So the answer is 2.4. Okay, 2.4. Right. And lastly, how much your standard deviation is a square root of NPQ, right? Your NPQ is 2.4. So just do the square root. So how much that we are supposed to get? Okay. So the answer is 1.5492. Then settle. 2 marks, 2 marks, 2 marks. See how easy it is, right? So that is your example 1. Now example 2. For example 2 here, okay, a group of teacher, the mean, okay, the mean and the variance. So mean, the mean is equal to 6. Okay, the mean of teacher who own the proton car is 6. Okay, and the variance is 2.4. Now the story is about own the cars, all right? The teacher, okay, in your school own a proton car. So this is the mean and the variance. The mean and the variance. So find the probability that a teacher chosen at random owns a proton car. So that means the question asking us is to find the P. How much the probability of teacher own the proton car in a school? So guys, there is no huruf P, there's no P, Q, etc. and also huruf N here. But we only have the mean and the variance. So how to solve this problem? Okay, mean actually equals to NP, right? Equal to 6. Variance stand for NPQ equals to 2.4. So guys, from here, how about 2 over by 1? What we are going to get? NPQ over by NP equals to 2.4 over by 6. NP cancel. So Q equals to what? So 2.4 divided by 6, then we are supposed to get 0.4. Okay, 0.4. So what that means? Q means the teacher, the teacher chosen doesn't have a proton car. Now we want to find the teacher that own a proton car. So to find P here, P is equals to 1 minus Q. Okay, because the Q equals to 1 minus P, right? So you want to find P, then 1 minus Q. Same thing. So to find P, 1 minus Q, 1 minus 0.4. So the answer is 0.6. This is your probability of teacher own the proton car. Settle. Guys, sudah selesai. Okay, hopefully you guys understand this question. Alright, next. What's next? Oh, activity already. So this activity 1, 2, and 3, I leave it for you to try. Okay, so try this one first. Okay, this is about mean, variance, and segregation only. So as usual, if you have a problem, please state your problem in the comment section. Alright. So do we have another? Okay, that's all. Okay, guys. So this is the final exercise for subtopic 8.1. Okay, for your information, chapter 8, we got 2 subtopic, 8.1 and 8.2. Now we already done the first part of the chapter. So itu sajalah untuk hari ini. So I hope that this topic is enjoyable, and I hope you guys can understand and also can solve the problem for this subtopic. Okay, guys. So I will see you on the next class for the next tajuk. Okay. Assalamualaikum warahmatullahi wabarakatuh. Bye, guys.